Hello everyone, my name is Han Zhenxiang and this is question 2 of homework 5 in the course probability and stochastic process. And in this question, the function of density function of xy is equals to the 1 over the a times the y to the power of 2 and times the y times the x, and this function, the y is bigger and equals to 1 and x is depend on the y it is bigger than 1 over y and smaller than y. And in this question, at first we want to draw the region of the density function of xy, and in this region we could find that there are three limited function, and for this function we could compute that this is y over 1 and this part is x is bigger than 1 over y and it is equals to y is bigger than the x 1 over x, and x is smaller than y. So we could draw this the y-x, and this is y equals to 1, so it is a blue line and it is over the blue line. And for this part we could see it is the red line, red curve, and it is for the right side. And for this part it is a black line, and when the x is equals to y, the is equals to 1 point, and it is the x is smaller than y, so it is the right side, left side, and all the part the shaded part the shaded part is the region of the density function of xy. So we could this question is okay, and for the question 2 we want to find the a so that the density function of xy is a valid joint density function. So we could integrate the density function of xy and it is equals to 1. So for the density function of xy is equals to the a 1 over ay to the power of 2x, and integrate this, it is equals to delta x delta y is equals to x is from y 1 over y to the y, it is delta x, and y is from 1 to infinite and it is delta y, and it is equals to 1. To compute this part is equals to, we could compute this part, the x it is equals to a times the y to the power of 2, and it is 1 over this, and times the y 1 over y to the y, the 1 over x delta y and it is equals to, this part is ln x from y 1 over y to y, it's ln y minus the ln 1 over y is equals to 2 times ln y, and so this function is equals to y from 1 to infinite, the a times y to the power of 2, the numerator is the 2 times ln y and the delta y. For this part, we could use that function to compute this, and it is, we could put it into delta, and the 2 over a is from the above former, and it is ln y and the delta y 1 over y, and it is minus, and it is equals to the times the minus ln y times the y 1 over y from 1 to infinite times because this is the minus, so there is a plus, and from one integral from 1 to infinite, there exchange these two, it is equals to this, and it is equals to 1 or times the 1 2, and the integral of this is equals to the minus 1 over y from 1 to infinite. And for this part, when y is equals to infinite, it is when it's equals to 1, this part is 0, and it is 0, and when it is infinite and the line y is smaller than y, so it is also 0, so this part is 0, and this part is from 1 to infinite. When y is equal to infinite, it's 0, so it's 0 minus the minus 1 is equals to 1, so it's equals to the 2 over a and times 1, and it's equals to 1, so the a is equals to 2. So it is okay for this part. And for the question 3, we want to draw and find the fx and the fy. It is the merging density function, and this question, the fx, because the a is 2, so we could, the density function of xy is equals to 1 over 2 times the y to the power of 2 times x, and the density function of the margin density function of x is equals to the integral of y, and the y is from the in this part, in these questions, the x is from 1 to the power of over y to the y, so the y, so for the margin of x, it is a 2 part. When the x over 0 to 1 and the y is from x 1 over x to infinite, because x is bigger than 1 over y and smaller than y, so it is this function, and delta y is equals to 1 over 2. And when the x is bigger than 1 and the integral interval is from x to infinite, and in this part we could compute this, it's equals to the 1 over 2 times x to the power of 2, and we could compute it for more. It is equals to it is like just like the function in this part, and we could compute this it is the density function of x, and we could compute the density function of y is equals to the integral of the y is from the x and delta x part. The x is from 1 over y to y, so it's more easy from 1 over y to y, and this the density function of x y, and it is equals to the ln y over y to the power of 2, and when it is from y is from 1 to infinite, and other part is 0 value. So we could draw the two functions. For x, the density function is equals to two parts. This part is 1, x from 0 to 1 is equals to 1, and x from 1 to infinite, it is the curve, and this is the plot of fx, and for the density function of y, and it is this is from 1 to infinite, and it like this. And for the question 4, we want to verify that the density function of x and density function of y is valid density function. So we just could integrate the fx and the fy so that they would be 1. The integral of fx is equals to this part times this part is from 0 to 1, the 1 over 2 delta x times the 1 to infinite, the 1 over 2 times the x to the power of 2 delta x, and equals to 1. Is it equals to 1? So it is equals to, this is 1 over 2 times, and this is also, it is times, this part is the minus 1 over x from 1 to infinite. When the infinite, the value is 0, and the 1, the value is 1, so it is 1 over 2 times 1, so it is plus 1 over 2 is equals to 1. So the fx is the valid density function, and the fy is equals to this part, the y is from 1 to infinite, 1 to infinite ln y over the y to the power of 2, the delta y. And for this part is, we could compute it as also the above method, and to this part it is equals to this, and we could also use the above method. It is equals to minus ln 1 times the 1 over y, the value from 1 to infinite, and times exchange these two, and the delta ln y is 1 over y, and these two the integral of these two is equals to the minus 1 over y from 1 to infinite. When y is infinite, it is 0. When 1 is y, it is 1. So it's equals to 1, and this part is equals to 0. So it's equals to 0 times plus 1 is equals to 1. So the density function of y is also a valid density function.